So jumping back into 2.1, let's scroll down and look at some examples very quickly. Remember, we kind of went through all this. We're not just graphing anymore. Okay, we kind of went a little bit deeper with how a graph works. Remember, we graphed these yesterday. I haven't filled in your notes. Specifically, look at the second one here. Remember, that one turned into a circle. Okay. Kind of kept going here. We learned about the distance formula right here, where we could know that we have even proved how it worked. The best we found out the distance, all of this right here. Okay. And we showed how it kind of works back from the Pythagorean theorem. And then just work our way down to show how it comes from right there. Don't worry, we just started out with it. Going through any one of these, notice each one of these is a point. We could come in here at any point because of what we learned right after the end of class. We learned these little midpoint formulas. So we could actually find the halfway point between any one of those. If we kind of keep going down and look at another little formula we got right there. Okay, so that was that midpoint formula there. Okay. And then we got just some little exercises that we'll kind of go through today, just very quickly. Notice on this one, it's saying, hey, I'm going to give you a little chart, just like what I've been giving you. I'm showing you how to do. But you're going to have to come in here and you have to plug in what it says. And so notice for this one, they're giving you this first little column here. They're giving you a y value already. Okay. They give you an equation. They give you a y, then you just solve for x. Okay, very simple. We'll do a couple of these. These first two, though, I should be specifically look at them. What do you think those are? If you're given y as 0, what is that going to be called? When y is 0?
X-intercept.
X-intercept, exactly. So when x is 0, you're going to have a what?
Y-intercept.
Exactly. It's always going to be the opposite. So notice on those first two, they're giving you intercepts. Okay. And then after that, just some points. So for this first one here, let's jump right in. So we've got 9x minus 6 times 0 is equal to 16. Well, we know that anything multiplied by 0 is just 0. So that all goes away there. And you're just left with 9x is equal to 16. We can divide off the 9 and there's our answer. 16 over. Simple enough there, right? Notice the next one, same thing. We can do the other intercept. Okay, we come in here and notice now x is 0, so that's going to be 9 times 0 minus 6y is equal to 16. Once again, that goes away. Divide off by -6 off both sides, and you get y is equal to 16 over 6, that's a negative. But if you do it that way, you're going to get that ugly blue bar, right? So what's that actually going to change into? How about -8 over 3? You see how those work? Pretty much, okay. I won't go through all of them. We don't need to waste our time on that. What I would like to ask you though is what kind of line is this going to be? Exactly. Why do you know it's linear?
You're like exponent?
Because the exponent is a 1, exactly. There's no other. Now, don't get just hung up on the y, on the x being a 1, okay? If the y is a 2 and the x is a 1, then you're just going to have a parabola, but it's going to be laying on its side, okay? Anytime you see a power in there somewhere greater than 1, you're going to have a different type, okay? So just kind of watch out for that, okay? And of course, don't forget to simplify. Do a hard one. So hard one, you're probably going to have to go in and remember what triangles are. Here's your 3 points here. Determine whether or not the given points from a right triangle. If the triangle is not a right triangle, determine if it is isosceles or scalene. Who remembers what those are? Exactly. When's the last time you took a geometry class? Okay, so we all should know what a right triangle is, right? And I'm gonna draw these as best as I can. So there's a right triangle. Okay, obviously, because it has a right angle. Here. Okay. That right there is called an isosceles triangle. It means two of the sides are equal. Okay, so isosceles, two sides are equal. Scalene. None of the sides are equal. The little lines, that's kind of geometry, little things saying, hey, if I have a 1 here and a 1 here, that means these things are the same. Okay, that's what it's saying. Right here, scalene, no sides are equal. So that's the isosceles and that's the scalene, right? Okay, so we have to decide what this thing is. Few ways to do it. Okay, first off, what I did on this one is I did a sketch. On your notes, I did a sketch, but behind the scenes, I actually went over to Desmos and just plotted some points and kind of just see what do they look like. Okay, because then it kind of tells me, kind of opens things up. And then I had an epiphany right after that. After I kind of got to draw it out a little bit, I was like, wait a minute, look, there's something staring me in the face that I never thought about. Okay, so let's look at it this way. If I graph these, when I graphed them, they look like this. I had 1 here, I had 1 here, and I had 1 here. Well, look at what I get. Okay, here I've got -9, 6. Here I've got 9, 6. And here I've got 9, 1. But I specifically want you to notice, look at the 6s here. These 6s are dead straight from each other. Okay, the y values are dead straight. Okay, and then notice my x values here. These are dead straight. So that automatically tells me I have what? A right triangle. Kind of helps me out a little bit, right? Okay, so yeah, so that's what I did, how I kind of figured that out. Okay, so you're kind of seeing behind the scenes how I did it. Okay, does it work great? I mean, it did for me. Okay, so now, are you good with that part, kind of seeing it, how maybe that kind of works a little bit? Okay, well, let's pretend for 1 second, what if everything was different though? Now, I don't know if Hawks is going to do that to you. So what you might end up having to do is come in here and take each one of these points and do what? You might have to find a distance, a distance, and a distance. And then look, because remember, this one doesn't specify a distance, right? This one specifies it being right. We can tell that by our picture. But this one, if I get two distances that are equal, I've got a scalene. I mean, I've got an isosceles. If all my distances are different, I have a scalene. Does that help you out a little bit? Okay. Continuing on, let's look at this. What is the area of the triangle? Hint, make use of the midpoint formula if the triangle is isosceles. Okay. You're going to have to find the midpoint right here. That's why. Okay, for that one, when you look at the formula, okay. But let's look at this one. We don't need it because we know we're dealing with a right triangle. The area of a triangle is denoted by base times height divided by 2. Okay. You may say to yourself, how am I supposed to remember that? And how did you remember? Well, I didn't remember because I'm a math teacher. I remember it because I Googled it. Because you're in college algebra now, some things you're gonna have to Google. You're gonna have to, like, they're gonna give you things and it's gonna be like, oh, You have to go back and find them now, okay? So let's look at this. How did I do this? Well, let's look at my base. When I go back up here and look at my original sketch, which is why it's gonna help y'all a lot to sketch. I have a base here of this, right? And then I could have a height of, the base. I have a height right here. Is that gonna help y'all out? Okay, so look at what I did here. I'm looking at the distances of those, so I'm gonna have to put those into my distance formula. Well, notice I have right here for my A. Sorry. For my base. Okay. I have 2 points and they are. Let's see here for the base, it's going to be the what? 9 and -9, right? I got -9, 6, and then I've also got 9, 6. So there's my 2 points, right? For my height, I've got 9, 6, and I've got 9, 1. Each one of those I can put into my distance formula because that's going to give me the length, right, that I'm looking for. So I can come straight in here because I'm looking for the distance. So distance is going to be equal to, this is my x1, this is my y1, this is my x2, this is my y2. I don't want to forget that. Come directly in here, I'm going to put the square root, put a parenthesis, and remember the distance formula is what? You're going to have this x sub 2 minus x sub 1, right? And then you square it. And then plus y sub 2 minus y sub 1 and square that. The squaring takes away any sort of negative number you might have. And then we take the square root to get us back to a positive number. Okay. So then we're going to come right in here. Notice my x sub 2 is 9 minus -9. All of that is going to be squared. Plus, and then I have, what is this going to be? 6 minus 6. All of that squared. Take the square root of that. Notice you're going to get 9 minus -9. That just turns into 9 plus 9, right? Okay, so that's going to end up becoming 18, or negative technically, yeah, 18 squared. Which is going to become 324, which in turn is going to become 18, which we knew it would be, right? Because I squared the 18, but then I'm going to take it back, okay? Are you good so far how I did that? Okay, let's do it again. When you look at the next one, notice I've got x1, y1, x2, y2. Let's just start doing the same thing again. I now have my x2, let's come in here very large. X2 is going to be 9 minus 9 squared plus, you have here 1 minus 6 squared. 9 minus 9 just goes away. That's just going to become 0, right? So then we get 1 minus 6, that's going to give me a -5 squared, which is actually just going to turn into 25, and that's going to turn into a 5. And now notice I have everything I need. I have my base length, I have my height, I can put everything into the formula. Scroll down just a little bit here. So my area is going to equal 18 times 5 divided by 2. And that's going to equal 45. And the reason they're saying, I believe, for the isosceles is, remember, because you're gonna have a base here. Look at that. Then you got that little right triangle there that you can kind of take the point. It's so you can find that point right there and go up and get a distance, okay? Because if not, they're not giving you a height. Okay, because for the isosceles, there is no height associated with it. You're getting points from here to there, here to here, here to here. But you don't have this h, and that's what you need for that. For the isosceles, it's the same formula, but you need that height. Okay, so if you get an isosceles, there it is, right there. Not too horrible, right? Messy? Yes. Okay. On your midterm? No, not that mean. Let's see here. Trying to see if there's any other ones that are kind of hard and weird, and you are in luck. Given 410 and x2, find x such that the distance of these 2 points is 13. Separate with multiple answers. This is just a solve problem. They're already giving you a distance, and then they're giving you 2 points, but notice one of those points is a variable. So you're just solving for that variable. Okay, so instead of this being d is equal to the square root of all that stuff, you're going to already have a d. It's going to be the 13, and then you've already got 2 points in there, and you really just got to just do the math, get everything kind of combined together as much as possible, and then start getting rid of things like you learned. Okay, does that kind of help out on that one? Look at my notes if you get too lost on it. By the way, you will get 2 answers. Okay, because it find all x's. Okay, and I'll be honest, that one threw me whenever I did this one. I try to go and do a lot of y'all's homework before like classes start, like about the week before, and I kept getting that one wrong. I was like, then I remember, oh, all. You know what I was forgetting?
The I?
No, there's no I. You can't have an I on these. You're gonna have a real number. You're dealing with a square root, so eventually at some point there, I was taking the square root, and guess what I was forgetting to do? The plus or minus. Remember, because every time I said you take the square root of one side, because eventually what's going to happen is you got this 13 hanging out over here that's kind of by himself, and he's just kind of sitting there chilling, right? All the math is happening over here on your right side, whereas your 13 is over here. Eventually, at some point in time, you're going to get all that simplified enough to where there's just a square root. Okay? Well, you end up having to take the square root of some other stuff, and lo and behold, okay, you got to end up doing your plus or minus. So does that kind of help out a little bit? Okay. So kind of watch out for that. Okay. Because everything you square stuff at one point to get rid of the square root, but then you end up having to take the square root again later on. It's kind of a process of going 2 steps forward, 3 steps back to go 4 steps forward again. Okay. So just kind of watch out for that one. That's sometimes how math works. That's why people get mad at it. Okay. How do we feel about 2.1? We all right? It's not due for a while, so we're okay. All right. There we go. Let's jump in. 2.2. Circles. And just so you know, by the way, the lectures are loading, okay? 1, 5, and 1, 6, I still can't get them to load for some reason, but my notes are there. But every other lecture is being loaded in every day, along with my notes. Notice here we have a circle with the center being HK, okay? Notice HK is just a point, okay? It's nothing special about that point. It is not the origin. It is not 0, okay? We can kind of designate it as an origin, okay? If we want, we can call it an origin. It does help out when kind of doing a proof of this, okay? But once again, this is another one that we can derive using the Pythagorean theorem, because I'm about to give you the formula for a circle. And there it is right there at the very bottom of the screen, as you can see. We can use this, looking at it this way, I've got a squared plus b squared is equal to c squared. But we need to define some things. Remember, we have an A, we have a B, and we have a C again. Okay? My A is going to equal X minus H. My B is going to equal Y minus K. And then my C is just going to equal to R. R being, for a circle, what's that R going to be? The radius, right? Okay. Put everything into the formula. Okay. Formula correctly. X minus H squared plus Y minus K squared is equal to R. Notice that H and R are the coordinate points. R squared is the distance to the center. Okay. Yes, because I forgot to square that. Okay. I want you to be aware of something. So notice, do you remember, everybody kind of remember the point slope formula that I gave you like last semester or whatever? And it was like y minus y1, that one, and then it was equals m x minus x1. And you literally just plugged in a point. Like all you needed was 1 point. And then you could just plug it in. You put the y at 1 point, you put the x at the other point, you were good. This is the same thing. It's saying this. I have an x value, okay, right here. But to find out what it is, I'm subtracting the value they gave me, okay, the original value, okay? So that's why that HK, they're going to give you that, okay? And so that's going to be your little midpoint inside that circle, okay? So this right here would be called the standard form of the equation for a circle of radius r and center HK. Okay. Good so far? Okay. A little bit weird because it's something new. You've never seen this before. Okay. Let's continue on. Not horrible. Don't remember. But it does kind of bear fruit because what did we see in the last lesson? We saw that x2, y2 pop up. Anytime you see that, you're going to have a circle. Anytime both of them, and it is kind of weird because x squared makes a parabola. Y squared makes a parabola. But when you combine them, you get a circle. Okay. So, and that's how that works. That's how that will always work every single time. So let's scroll down. A lot of this, and you're going to notice in your notes, maybe not in here. Yeah, I did. I give it to you. I'm graphing stuff in Desmos a lot in this one. Okay. It does help you. Okay. It won't help you on a midterm. Okay. But this will help you in the background. So let's look at this one. Find the standard form of the equation for the circle with the given properties. The center is at -6, 5, and the radius is 5. Okay. So let's remember what our definition is. Okay. The definition of a circle is this: x minus h squared plus y minus, k squared is all equal to r squared. Well, we have 2 points, okay? H and K. Not X and Y, okay? H and K. Because H and K are the center of that circle. Your X and Y are other points somewhere else. Okay. So when we start putting everything, remember the formula. Okay. Remember this. Okay. It's going to help you out, especially when learning to just read these later on. It's going to help out a whole lot. So notice we have H and K. So we would come right in here and start go ahead and replacing everything. So let's put everything into the formula. I have an H. Well, that's going to be X minus -6 squared, plus I have a k of y minus 5, and then I have a radius of 5 squared. Cleaning it up, notice the x turns to what? X, negative and negative make a what? A plus, right? A positive. X plus 6 squared plus y minus 5 squared. And then believe it or not, and I didn't check this on your Hawks. In Hawks, they'll take 5 squared or you can put 25. Okay, so you can do either one. And then, of course, notice here, I graphed it in Desmos. Okay, we have a center right here. And a coordinate point of -6, 5. Can scroll down just a little bit, you can see it, because notice there's my -6 right here. And then here's my 5. Right there. With radius, what? 5 squared. Right? Good on that one? Neat thing about this one, believe it or not, you can start dissecting this in a lot of ways, and this is just extra information for you. You now, because you have 2 points, you could also come here and find out the distance here. Right? You're actually starting to see slowly but surely the very beginnings of the math about how they started to develop pi. Okay, because it's very easy to find the area of a circle, area of a square, right? And so they said, well, how about the area of one big circle and then, or one big square and one small square? And they started doing the ratio of the two, but they kept adding sides. So instead of 4, they go to 5, then 6, then 7, then 8. So that's how come you can find some pretty accurate definitions of pi all the way back to the Babylonians. That was about 4,500 BC. Pretty straightforward on that one. Can you kind of recognize it a little bit? Okay. It is, like I said, it is one of those that's just a little bit tricky. So just be careful. So let's do some other examples here. Find the standard form of the equation for the circle with the following properties. Endpoints of the diameter. Oh, notice the diameter of the circle now. Okay, are 11, -9, and 1, -11. I'm going to draw you a picture. I have you another picture here, so I'm going to be careful where I draw because I don't know if I pop it up on your notes here. I don't think I do. Okay, on your notes, I actually show you a better picture because I graphed it for you. Okay, but this is what you're seeing. You got 1 point at 11. So let's look at it this way. I've got a 1 point here. Got a circle. We know we got a circle. Okay, it's telling me that. But the endpoints are going to be, one's going to be at 11, -9, and then one's going to be 1 at -11. So a good thing is like you're going to have different points at different spots. So let's just kind of just arbitrarily draw this. I've got a point here and I've got a point here, but they're at 2 different exact endpoints, right? What do they not give me though? What do I need to have? What point do I need? I need to have the center. Midpoint formula. Remember that from the last lesson. So you're looking for that midpoint formula. So they've given me 2 points here. I'm looking for this guy. Well, that's nice. Okay. So here's what we do. Midpoint formula. I've got 2 points here. Excuse me. I've got x1, y1, x2, y2. Midpoint formula says this.
you're gonna have x1 plus x2 divided by 2. I apologize, I don't know what's wrong with my voice today. Then you're gonna have y1 plus y2 divided by 2. Let's put it all in. Notice for this first one, I have 1 plus 11 divided by 2. And then I'm gonna have what here? I did x2 and x1, but doesn't really matter. Then I have this -9 minus -11, right? All divided by 2. Do the math to that. You're gonna end up getting 6, comma, -10. And there is my midpoint. There's my 6, -10. There is my H, and there is my K. So I found my center. Good so far? Okay, we're not done yet. There's a little bit more to do. So now, pick a point. Doesn't really matter. I'm gonna use this one because it's what I use my notes, so that way you're not confused. Is that too dark for everybody, or can everybody see that okay? I'll go back to yellow just in case. Okay. Now I have a point, but I'll also have a center. So, but notice I don't have a radius. Do I? Well, I need to find the radius. That's easy enough. I've got a lot of points now. So let's look at this. I've got r squared is equal to, hey, x minus h squared plus y minus k squared. I have an h, I have a k. I also have an x and a y. I have the choice of 2. Just decide which one you want to use. And just plug those numbers in. I'm using the 1 and -11. So notice I'm going to have r squared is equal to, well, this first one, I'm going to have a 1. Okay, minus, okay, 6. Why 6? Because that's my h value right here. All of that has to be squared plus, come up there, look, I'm going to have this -11 minus -10 squared. Are you good with what I just did there? Okay, because notice here, that -11 is coming from this point up here. The 10 is coming from my k value right there. I'm plugging everything in because I've got to try to find that r squared. So I've got to plug in some value so I can find the radius right now. Do the math here, you're going to keep going. You're going to end up getting -5 squared plus, this ends up being -1 squared. Okay, it's all said and done, you end up getting 26. So now we have a radius, right? Now hear me out. You can square that. Now you could go ahead and take the square root of that if you want to, or whatever. This is that number, okay? So how you put this in, I would just come here and go x minus 6 squared plus y plus 10 squared is equal to 26. That would be some number squared, okay? It'd be some ugly number squared because it's not a perfect square, so I just keep it as the 26, okay? Good with that one? I believe that's how Hawks wants you to do it on that one. So it's got a little bit of a twist in there, doesn't it? Are we good with that one? A little bit weird in it, a little bit, not horrible, but definitely want to like take your time on it.
And then here's the weird one. This is the one, I thought it was gonna be yesterday's. But it's today's. Find the standard form of the equation for the circle with the following properties. It gives you the center. The center, 8 1/2, okay? Tangent to the y-axis, okay? Tangent. Tangent to the y-axis means x is 0. Okay? Was math okay?
Thanks.
Huh?
Baby.
Abby, what was wrong with it?
I.
Check my math. Always check my math.
It's because for -9 minus -11, wouldn't that be 2?
And oh, it would be, wouldn't it? -9, that'd be -9 plus 11, right?
Yeah.
2, that term, but 2 divided by 2 is
1.
1. Didn't I get a 1? Right here? Or did I put a -1? Or does it matter?
No, it's 0.
Because it'd still be end up being -1 squared. Or 1. I think on mine, I did a negative. It's the way I did the math on mine. I think I did it backwards. Switched them around. Okay, so I ended up getting but anyway, you're still gonna get a 1 at the bottom here, right?
Yeah.
Yeah, so you're still gonna get that. Because when you square it, what's gonna happen to that 1? -1 squared is 1, but 1 squared is 1. So yeah, I think what it is, when you see my notes over here, and I think I went backwards on my notes like that, so.
So that wouldn't affect, like, since you have to plug it into K into the to find the R.
On right here on that midpoint?
Yes.
No. No, because you're gonna be squaring everything. Okay, so it would be if they wanted the exact point, but notice that 6, I got 6 -10 for my center. That's the point you need. That's the important point. Is that gonna help you out a little bit?
Yeah.
This part right here. See my X1, double check, because I want everybody to make sure you're getting it. Even if I make a mistake, trust me, sometimes I do these kind of quick, so let's double check. We have time always. Let me erase that, because that's throwing me that little bitty. That's not gonna work. Oh, got it. I was trying to erase it without erasing everything on top of it. Okay. So we've got X1, Y1. Okay, I've got this. X1, let's kind of make sure I write everything the way I was supposed to here. X1 is going to end up being 11 plus 1. And then we got Y1. Y1 is going to be -9. We're going to kind of just change that to a plus 11, right? That ends up becoming a, let's see, -9 plus 11. Ends up being -11, was it? Yeah, that's right. Write it correctly. -9 minus 11, right? That ends up giving us a -20 divided by 2 gives us the -10. So we're good there on the center, correct?
Wait, how'd you get? Wouldn't it be plus because of the 2 minuses? Wouldn't that turn into a plus?
No. You're subtracting a negative. You're thinking of multiplication. A negative and a negative make a positive when you multiply them, but we're taking -9, like you owe me $9, and then you're borrowing what? $10 more or $11 more. So now you're -20 in the hole. That can help you out a little bit. So then when I do the math for that, I still get my -10. 1 minus 6. So no, all the math works out. I was correct. Thank goodness. Okay. That help you out better now?
Yeah.
Okay, yes. Yeah, like I said, you're thinking of multiplication. Because when you're negative, this is how you probably saw it at one point in time. It looked like this. Say you had -9 plus -11. Well, what happens to a positive and a negative? Right here. They go what? Negative, right? So you end up having that -9 minus 11. Okay, that's why you get the -20 there, so. Good now? Okay. Go back over this one. Perfect. Okay. Find the standard form of the equation for the circle with the following properties. The center, they give it to you. They give me an H. They give me a K. Okay? So I know my H is going to equal 8. I know my K is going to equal 1/2. Okay. Tangent to the y-axis. That means where does this function touch the y-axis? Okay. Well, tangent, when it's tangent to y, just let me give you a little hint. Tangent to y is always where x is 0. Okay. So if your problem says tangent to x, y is going to be 0. Okay. Let me show you what that means. Okay. So the point tangent here is where y is equal, sorry, where x is equal to 0. So the point would be 0, 1/2. Okay. It's tangent. Okay. But I don't have a radius still. Okay. So once again, we've got some points here. We do have a point. We have an end point. Okay. And we also have a midpoint, a center. So we can plug everything back in again. Notice we're going to be looking for that distance. So we're going to come in here and go, okay, I've got D is equal to big square root. Well, I've got 2 points here. I've got 8, 1/2. And I've also got what? Sorry, comma, 0, 1/2. Okay. Good thing about this, you don't have to get hung up too much. I get it in the formula. It's going to say do y, do x, then do y. But then sometimes, does it really make sense that you can kind of do y first if you want? Addition's commutative. You can go backwards and forwards with it. Okay. So doesn't really matter. But notice here, I've got what? X's. And then I've got y's. Okay. And so my distance formula is going to be the square root of x sub 2, what? Minus, right? X sub 1 squared. If you got those backwards, the nice thing about getting those backwards, if you mess up, you're squaring them. So it doesn't matter. If you end up with a negative and some people got a positive, you square it, it takes care of everything. It's a very forgiving formula. Plus y squared minus y1 squared. Well, let's look here. Let's go and put 1s and let's put 2s. Come in here very carefully. X2 is going to be, I've got 0 minus 8 squared plus 1/2 minus 1/2. Well, I think we all know what's going to happen to that one. What's 1/2 minus 1/2? That goes away. Okay. Then we get 0, -8. Sorry, 0 minus 8. That's just going to be -60 or -8 squared. Is just going to be the square root of 64, which is in turn just going to give us an 8. And now, since we have a radius here, and we also have a center point here, do we have enough information to make an equation? Yes. We can come right in here and do this. Come in here and go, okay, well, how about I just do, let's see here, I've got x minus, remember, x minus h. Okay, so x minus 8 squared plus y minus 1/2 squared is all equal to 8 squared, or once again, the 64. Okay, remember, Hawks will take it either way. They'll take 8 squared or they'll take 64. I'm the same way. I don't care which one you give me. Okay, usually, to be honest, if you have 8 squared, put a 64 there just because
It's a number you can see. Okay. And that, ladies and gentlemen, is circles. Tangent looks like this. Whenever I show you. Like there on your graph, I show you actually pictures where I graphed it. Okay, so that's what tangent would be right there. See, it just kind of comes in there. Okay, sorry. Goes the other way with it. Because that's tangent to it. Tangent means it's never gonna touch that. That's how come the X is gonna be 0 right there. Okay, so. It's a weird word. You probably haven't heard a lot before until today. If you end up taking trigonometry, you're gonna use that word a lot. Matter of fact, there is a coordinate point called the tangent point. I believe, and correct me if I'm wrong, I think I had a teacher one time talk about it. In explaining it, this is in like a Cal 2 class, tangent's like a kiss. Because it's a line, and it's just a very simple kiss where this thing kisses it and goes off again. It just never touches it again after that. So. It's about the only romantic thing he ever said. And then after that, he just got really mean about math. Okay, so let's jump into 2-3. We might be able to finish it today, we might not, but remember, we're way ahead right now, which is good. We've built enough room that you shouldn't be too stressed about having to really kind of play. If you're waiting until the day before homework, that's up to you now. Okay, but right now, you've got a little bit of breathing room, okay? Fortunately, we still gotta kind of keep this pace up. This next one will be pretty simple for you. Now, I'm gonna be very honest, it wasn't simple. Until I realized I wasn't following the curriculum exactly, because there was some stuff in there, I was like, holy crap, they want y'all to do the math to this. And I was doing it, and I was like, I teach this in statistics, and I let people use their calculator. In fact, I tell them, don't do the math to this, it's too ugly. And I'm like, no wonder these kids did so good. Well, no, I forgot to push the curriculum button. And it got rid of all those for you, so there you go. So. Here, we're gonna start running linear equations in 2 variables now, okay? So a linear equation in 2 variables, you've done them in 1. Say the variable x and y is an equation that could be written in the form ax plus by is equal to c, where a and b and c are constants. A and b are both non-zero. This form of such an equation is called standard form. Remember when I say the word standard form, it is it in its original form before we start doing any sort of manipulation. So sometimes you're gonna see these equations in other forms and have to get them back into that form. Just like what you do with the quadratic formula. Not quadratic formula, the quadratic equation. Sometimes you see it in other forms, and I'm like, what do you gotta get to? Equal to 0. Okay, well, that's its original form. Everything's off to one side. Okay, so that would be its standard form. Notice on this one, something we've been talking about a lot, given a graph in the Cartesian plane, any point where the graph intersects the x-axis is called an x-intercept. Anywhere the graph intersects the y-axis is called a y-intercept. All x-intercepts are of the form c, 0, and all y-intercepts are of the form 0, c. Well, this is what you're seeing right here. You have a line. Notice I have 2 intercepts here. I have the y-axis, I have the x-axis. I know everywhere on that y line, x is equal to what? 0. I also know here, everywhere along the x-axis, y is equal to 0. So this is why this one will be c, 0. So once again, as you can see, for x-axis, y is 0. For y-axis, or y-intercept, x is 0. It's always thinking opposite of it, okay? So far, so good. I mean, this is like stuff right here. You've seen this.
Another thing to note, horizontal and vertical lines. I give it to you right here. Just gonna show you the little definition, horizontal and vertical lines. Vertical lines will always be of the form this, vertical. X is equal to just some constant. There's no y value there. Horizontal. Y is equal to some constant. You can see this down below in my little formula here. Notice I have a vertical line going up and down, okay? That line will never, ever, ever, ever cross the y-axis. And it stays consistently on one x line, okay? And for that right here, it's going to be where x is equal to 1. So this will be where x is equal to 1, and it will be that way always. Notice I also have a horizontal line, think of horizon. Okay, and for that one, we've got y is equal to, -3. It should be worth noting, okay, and we're going to be getting into this, but this is review. When x is equal to 1, or anytime you have a vertical line straight up and down, you have a slope. We're about to get into slopes, but I want to go ahead and kind of tell you about this now. The slope of any vertical line, can anybody tell what that is? Anybody remember? Undefined. The slope of any horizontal line is always going to be 0. Okay? Always and forever. Because whenever I show you the slope formula again, which you've seen before, that's that M of your slope intercept form. If you actually try to find the slope intercept form of this vertical line, your zero is you're gonna end up with a 0 in the denominator, and you can't divide by 0. And so therefore it's undefined. It's an undefined slope. But it is something you need to remember. It's on tests. It's here forevermore. Okay, that undefinedness of a vertical line is always here. It's in this class. It was in intermediate. It'll be in trig. Okay, it will be in calculus. It's everywhere. Okay, if some things being undefined. Notice I promised you that this lesson was going to be very simple. Consider the following equation. We're already in the Hawks things. Find the x and y intercepts if possible. Okay. Well, let's take a look at this one. Notice always whenever I'm trying to find points, I'm going to go ahead and draw myself my little graph here, or my little chart. X-intercept here. Y-intercept here. X-intercepts, what has to be 0? Exactly, so put a 0 there. Y-intercepts, what has to be 0? There you go, now you have stuff to solve for, don't you? So notice you can come in here for the first one. If y is 0, I'm going to come in here and just go 6 times 0 minus 3x is equal to 9. That goes away. -3 divided by -3. Good on that one? Okay. What's 9 divided by -3?
-3.
How about the next one? Do that one. Good on that one.
Hawks will probably ask you to graph these after this, okay, just so you know. Which is easy enough. Can everybody turn a improper fraction into a mixed number still? So you can kind of see how to do it. What it would be the 0.03/2? That's okay, we kind of need to remember how to do that. So notice on this right here, you do have a point at -3, right? Okay, that's gonna be my x-intercept. -3. Okay, so we go to -3, 1, 2, 3, there it is, a -3, 0. But then I have another point where? At 0, 3/2. Here's how you figure it out. 1, how many times will 2 go into 3? 1 time, right? How many's left over? 1, keep the denominator. Or do it this way. 2 divided by 3. 2 will go into 3 1 time. 1 times 2, 2. There's 1. So it becomes this 1 and 1/2, or 1.5. Or use your computer, or use your calculator and do 3 divided by 2. Okay. But that's the way you don't need to lose that skill. Okay. This part here is your whole number. This part here, the blue, is your numerator. And this part here, okay, is your denominator. Okay. It's a good skill. But then now we have it. Okay, so 1 and 1/2. So I've got 0, 1 and 1/2. So where's that going to be? It's going to be roughly right about here, right? And then what do I have? Well, 2 points makes a what? And there's your line right there. I believe Hawks will let you grab the points and move them around. Okay. Or it may just graph it for you. I really don't know exactly how Hawks exactly does that one. To be honest. Tell me without really having to look at it very carefully, consider the following equation. Okay. Will this be a horizontal or vertical axis? Sorry, horizontal or vertical line?
Horizontal.
Horizontal Y.
There's no X.
There's no X, exactly. So when there's no X, you just have a Y value. You have something of the form Y is equal to C, which automatically tells me this is going to be a horizontal line. And now we just got to find out, where is that line? Where is that line crossing the Y-axis? Well, let's go ahead and just do some easy math. And let's just do, how about divide by 8? Y is going to equal a negative, and a positive always make a negative. 64 divided by 8 is?
8.
8. I was like, oh no. There you go. So that would be the point if you had to graph this. You have a Y, you have an X, then it come down 1, 2, 3, 4, 5, 6, 7, 8. There's -8 right there. So it would be coming right here, right? And so that would be the point what? 0, -8. And then let's do one more and call it a day. And then you're actually done with 2, 3. So we are plenty ahead. So we can come back next week and keep moving and chugging along. Graph the line by locating any 2 ordered pairs that satisfy the equation. Round to the nearest thousandth if necessary. Now, to some of you, you're going to look at this and go, man, I see it. I've seen this type of formula before, and I can go ahead and do it. Or you can just plug in points, okay? In your notes, I show you both ways, but I'm only going to show you the chart way right now because, yes, we are going to get back into the slope-intercept form and point-slope form again, okay? But if you needed to, go ahead and just plug in numbers.
Does it tell you specifically, now hear me out, does it say specifically find me X and Y intercepts? No, it just says find points. So you can pick any point you want. I'm pretty sure they're gonna ratchet you on what points you're actually allowed to have, okay? Like they may say they can only be between here and here, okay? But I will tell you this, if they're not, I do like to go ahead and throw in a 0 at least one time, and I usually make it on one of them. So I can come in here and go y is equal to, well, hey, 0 times anything is what? 0. So what am I gonna be left with that one? Just the -4. And so there's a point. And then let's have fun with the other one so you can kind of start seeing it. I do have a fraction there, don't I? If I want to just get rid of that one fraction, going back in time right now, if I just want to get rid of that one fraction, what would I multiply it by? 7. I'd find the denominator, right? If it has 3/7, and if I multiply that by 7/1, that will reduce out that fraction. So why not reduce out that fraction by multiplying my x by 7? Right? And then we would have this. Y is equal to 3/7 times 7/1 minus 4. Well, those just reduce to a 1. And that gives me y is equal to 1 minus 4, which is just going to give me what?
-3.
I get a what?
-3.
Yep, -3. Oh, sorry. There's a 3 there. I did it wrong. Why did I do it wrong? I turned it into a 1. Watch it not be a 1. I just followed along like little lemmings. Don't do that. Look, these 7s go to a 1. There's still a what? A 3 right there that I've got to bring down. So 3 minus 4 gives me a
-1.
-1. And there, I've got 2 points. 0, -4. So 0, -4. 1, 2, 3, 4. And then what? 7, -1. How straight of a line I can draw. So we can finish this on a good review. Hey, does anybody remember what this guy is right here?
Slope.
Yeah. That's the slope. What is it telling me? If my slope is 3/7, what is that saying?
Go up 3 and then right 7.
Yeah, up 3, right 7. Remember that? Isn't that it right there? Look. 1, 2, 3. 1, 2, 3, 4, 5, 6, 7. And that's a great place to stop. Good review for that one for whenever we come back and start going back into what slope, probably gonna be jumping into slope intercept form. And then point slope form and stuff that you've seen all before. So is college algebra as bad as you thought it was gonna be so far? That's not till chapter 5. Chapter 5 is usually when people go, this class sucks. Really hate it. All right. Trying to think. So we're at 2-3 right now. Someone's gonna have to remind me of that, okay? Because we are plenty ahead. This lecture will be downloaded today. Did that help y'all out earlier about that one little problem we had?
Yeah, what I did wrong was that I thought it was, we were supposed to subtract them, not add them.
No worries, no worries. Some of the biggest things I do, and believe it or not, sometimes up here, and I'll have to do it today, I use notes here, right here, work things in class, and sometimes I find mistakes, so that way I can correct them on my notes before I actually download them to y'all too as well. Sometimes I keep intentional mistakes in there as well, so that way you can see if you can't find them. Okay, you get nothing for it, but it's good to kind of say, hey, what did you do? Okay, nothing major, I've never done anything hard. Do we have any questions over anything coming up? When's your first chapter test is not due till,
Wednesday.
is it Wednesday? That was yesterday, wasn't it?
What do you mean next?
Next Wednesday, is it? Okay, I was like, that was yesterday. Okay, so we're good on everything. Anybody doing good on everything? It looks like I did check everybody's homework. It looks like everybody's staying caught up, which is good. I would suggest probably trying to get ahead if you can. Okay, I know it's tough. Don't get ahead at the expense of doing anything fast. Okay, just try to see if you can't get a little ahead. We're ahead enough that I I can't promise anything. I might try to do a little bit, remember, we're gonna have a little bit of a review day, but you're gonna need to look over the review. Okay, and see what you're gonna have trouble with, okay, and email me. I did have to re-download the review sheets last night. There was a word problem on there that you don't have in your homework, and so I got rid of the word problem on your review. Because how am I gonna have you review something you never learned? Okay, and so it's not there, and I made sure to double check that word problem is also not on your midterm as well, so you're all good. All right, guys, I'll see y'all next week.